No, wait. All right, we're getting started right now. Just all right, is everyone? Hey, Fernando, we're getting started. All right, welcome everyone to our general meeting for Space City Rocketry for October 19th, 2021. Here's what we have today for the agenda. So we're gonna be talking about some upcoming events we have. Of course, the weekly shout outs. Gustavo is gonna be talking about the payload challenge we brought up, our Kahoot, sub-team updates, and then our avionics lesson, and finally, questions all the way at the end. So for upcoming events, right before everything, I want to thank everyone who went to our social this weekend. It was fun. There was a lot of food. We got to meet members and all the sub-teams getting to know each other. It was great. We'll have one maybe closest to the end of the semester, so we'll announce that later. Some other events we have coming up, and this is a really important one. That's why it's in red. That is the dry runs for Oberon. They're gonna be at the lab, and they're gonna be this weekend. So the first one's gonna be this Friday at 1 p.m. We're gonna cap it around like 12 members, and we will send out like a form to see who can make it. Then we're gonna have another one on October 23rd, which is Saturday at 10 a.m. And then Sunday, we're gonna have 2 of them at 10 a.m. and 1 p.m. There will be limited space for each run. And I'll just basically to get everyone to know more about how you assemble a rocket like Oberon. It'll be fun. So I encourage everyone, if you're available any of the 3 days, to make it. Of course, you don't have to make it all of them. If you make it a one, that would be perfect. And then study sessions, just I guess as midterms are coming, and then as finals are getting close too. We will have just random study sessions whenever anyone wants to study throughout the week. We'll do them at the Nook and the SR second floor, library, or anything. So watch out for those. Shout outs. We want to give a couple shout outs this week. I want to give a shout out to Ravi Desai. Yeah. It's always really hard to take over a new sub team. And Ravi, I guess this year with analysis is brand new. He's been working really hard trying to get everything together. And their role also is very different from any other sub-team in SCR. It will be a very important role. So just thank you, Ravi, for the hard work. Also, another shout out to Ozzy for last week's presentation and also for today's Kahoot. And then one final shout out, Haley brought this to my attention, to Brandon. He went above and beyond, I'm quoting Haley there, to learn Open Rocket and produced an estimate for Zenith. So thank you, Brandon, for the hard work. That's it. Every week we'll be shouting out new members. Now Gustavo's gonna be talking a little bit of our payload challenge.
Awesome. Happy to talk about the payload challenge with you guys. So for Zenith, like every other rocket that goes on at Spaceport, we win points for having a payload, something scientific that does a cool thing on the rocket. If we don't have a payload, there's really no point to have a rocket. It's just launching stuff for fun. So to have the payload do the things that we want it to do, it has to fit within a 10 centimeter by 10 centimeter by 30 centimeter, or roughly 4 by 4 by 12 inch casing or like size. And it can do pretty much anything you want to do with some limited exceptions. And I guess the biggest constraint is that it has to be 8.8 pounds. So uh, what we want to have is a group of anywhere from 3 to 6 people who can, come together, design something that could be fit into this payload and launch it and see what happens. And so, you might be thinking, well, that sounds interesting, but what is in it? So, some things that we can offer for you is design and fabrication experience. So you can, have, some experience to add to your resume, designing stuff, having contributed as a team, communicate with other sub teams and all this stuff to get this payload to work. And there's a factor for the actual competition where when you're at the competition, you can talk to different judges,
I have to go parts.
different recruiters and industry
Todo así, Romina.
stuff.
¿Por qué no puedo hablar normal?
Hello, you might want to mute yourselves if you guys are making noise online. Thank you. And well, at Spaceport, you can talk to industry leaders and recruiters from all these great companies, and there's been plenty of people who get hired right on the spot there. So that's a big win if you happen to go to Spaceport with us, as well as for the competition. If you make your payload and it fits all the requirements for the SDL payload challenge, the first prize or first place prize would be $750. Second place is $500, and third is $250. And right there on the right, you can see a payload interest form, little QR code. So if you scan that because you're interested or whatever, we'll be hosting an info session going over all the actual requirements in detail. And we'll also explain some examples of what other people have done in the past. I know there's been some people who do a little drone or a weather balloon that deploys from the rocket, or some people have done a vibration capstone. So the capstone keeps it from vibrating, and you can get better measurements on data and all that stuff. So it's really interesting, and I'd suggest you guys go at least to find out what it's like. And I'm excited to work with you guys on the payload.
Thank you, Gustavo. Okay, so next up is the weekly Kahoot. So Ozzy, I don't know if you wanna you wanna run the Kahoot here. So I guess the price for this week is gonna be a free dessert or a coffee from the Nook. Not both? No, not both. Actually, you know what? Both a dessert and a coffee from the Nook for this one. No, you cannot. Redeemable anytime. So when you want to get it, just let me know. I'll get it for you. So this week is going to be about top propellants. Last week we had a lesson over that with Ozzy. It was very informative, and I do want to thank you for that. And then next week is going to be, sorry, this is next week. This week we're going to have a lesson over avionics, and we're going to have a Kahoot about it next week. The price for next week will be a little bit different. We'll announce it then, but right now, let's go to the Kahoot. The leads cannot play the Kahoot, unfortunately, or very fortunately. No exceptions. All right, let me bring it up here. I'm sorry, I'm having. Just grab the green thing and drag it. The green thing, all right.
Awesome. All right, let me join real quick.
You can have that too.
No, I'm kidding.
Why'd you lose?
Yeah, I probably would lose. Yeah, go ahead and play, man. It's funny. It's fun. I hope. What? Go for it. I mean, even if you win, we'll just kick you off the podium or something. Something funny like that. It could be Yo Mama here. Yeah, trust me, I feel like this Kahoot, you could answer it without really knowing the lesson, but it should be pretty good. Who's this? Who's this with the fish? I'm messing with you. Oh, wow, okay. I mean, if you could put a fish on there, right? I guess let me know when to start. I don't know how long to wait.
Give me like 10 more seconds.
10 more seconds.
Are you looking at me?
Who?
P.
P? I mean, it's probably like a nickname or something. I don't know, man. I don't judge. See, they got R with an R spelled backward. Yeah, it could be like foreign. I don't know. What?
It's Russian.
Oh, okay, yeah. So that's why I said foreign.
It's Russian.
Okay, all right, let's go ahead and get started. It looks like no more new people are joining. Okay. Duplicate of solid motor quiz. All right, first question. Which of these is not a solid motor component? Super simple, super simple. I won't name them off because I feel like.
Can you get rid of the audio settings?
Oh, this thing? I apologize. I won't name them off because I feel like I will like emphasize the correct answer, so. Okay, not what I expected, is not a solid motor component. That's fine, I guess. Really pay attention to the lesson, but.
Hey, leave.
Leave. No, we'll let her play, we'll just kick her out later. All right, second question.
Last question.
The shuttle's solid rocket booster was 2 times more powerful than which famous liquid engine? You guys don't know these?
Oh,
You guys don't?
that one?
Yeah, that one, dude.
Yeah.
Those, yeah.
You guys can,
Bro, who doesn't know the RD-120?
you guys get extra points if you can tell me what country that one's from.
Russia?
Which one?
Okay, all right. So the RS-25 was actually the liquid engine on the shuttle, so it's not 2 times more powerful than that one. But yes, it is the F1. Oh, Emily, I thought you knew your engines, man.
Too quick.
Where's the next?
That was it. That's the game here.
Oh. What is the name given to the following grain geometry? I went over these, so you know. What?
Moon.
Tubular.
His lifesaver.
It does look like a lifesaver. I think I made it cropped it. Oh, I did get you guys. All right, I'm surprised. Yeah, so I should have done it a multi-question. Now I feel bad. They barely go off tubular, but 90% of the time it's called a Bates grain.
Oh, that's great. Why is it called Bates?
It stands for like some ballistic testing. It's like an acronym. They used it back in like the 50s and 60s. So it's like a standardized test that they still use. All right, question number 4. What is the name given to the following grain geometry? This one's a little different.
Oh my God.
I thought this picture would look a lot better in person.
Well, does it?
It does not. It looks a lot worse.
Is that a bowling ball?
Yeah.
Well, that's definitely not a small moon, but spaceship's not the answer.
It's the Death Star. Yeah, I do got MS Paint. Okay, all right. Yes, it is the moon. It's just an offset circle. I assume it looks like, I don't know, like an eclipse or something. I didn't name them. It was like a bunch of scientists in like the 50s. All right, number 5. Our Loki M3000 uses which of the following fuel types and how much of it? Look at Carlos, man, killing it in that picture, bro. Gonna like drop some elites here, man. You guys are gonna go down a couple pegs. Ooh, actually, it's a surprisingly amount. It's a surprising amount of propellant. It's 9.5 pounds. Man, did I make it that hard? I thought it was easy. I didn't make that hard. I like mention the F1 engine in the presentation, and I throw in a bunch of random letters, and y'all pick them. All right, next question. Which of the ingredients below is the main fuel component for ammonium perchlorate? This one, I thought this was gonna be the hardest one. So if you guys, I'll cut you guys some slack. It's a trick question. This one's really bad. Yeah, I better be. Oh man. Okay. Maybe I did.
Oh,
I'm not doing a good job in the lesson. Did you guys not listen?
In that right now.
In the game. Oh no, I wasn't gonna click it. It was just like, it's terrible. You're like that teacher who just like completely gives up halfway through the semester.
No one got
All right, next question. Approximately how much of the space shuttle's thrust was provided by solid propellants? I made the big deal about this one. Come on, you guys have to know this. Nothing. Percentage? It's a percentage. 80 newtons was provided by. There you go. Okay, now that makes me feel good. It is 80%. Goose, get out of there, man.
This has just been watching.
What was the name of NASA's prototype rocket that used a shuttle solid rocket booster in its main stage? That's actually it right there.
Yes.
If you guys know anything about rockets, you know like 3 of those aren't it. No, they're not.
Yeah, that helps so much.
Oh no! Do you guys know what the Atlas V looks like? All right, I won't. I'll stop. I'm sorry. I'm getting a little one. Maybe it's like a thing only I know. I know a thing or two about rockets. See, Jordan knew. All right, which of the following current rockets does not use solid propellants? I really hope like at least like 90%. No, it's not that one. That's actually a solid rocket booster on there. Okay, all right, good. No,
Okay, has 2 boosters.
I remember.
well, no, the Delta 4, not the heavy, the Delta 4, they have like different configurations where they actually strap on boosters. Well, the Delta 4 Heavy is just like 3 big boosters on there, liquid boosters. All right, last question. Oh, I keep forgetting it's down here. All right, last one. Please. Which of the following is a nominal port-to-throat ratio range for hobby rocket motors?
Yep, green it is.
Green is the only answer.
It's a multi.
Wait, what?
So you could just.
It's yes. The answer is yes.
The answer is yes. Okay, it is 2-3. I threw that one in there just to
How many total?
just to see who like, huh?
Because
I did mention it, like by voice, but whatever. It's fine. All right, let's see. Isabel, not bad. Goose, bro, how did you lose, bro? All right, number 1, Adrian. Oh man.
one that paid attention.
All right, sorry for the hard quiz, guys.
Just because I got second place, I will give Isabel a dessert as well from the Nook.
Dude, that's real nice. Nice guy.
Thank you, Ozzy, for the cahoots. That was,
I'm not making cahoots again.
that was a tough one. That's a tough one. Okay, so we're moving on to sub-team updates, our weekly sub-team updates. This is the order. First, we have avionics. V, you like to come up?
Right, so this week, we finished up splitting up into our SRAD groups. So we kind of went over with all the new members about what our different components of SRAD were, and we kind of finished up showing the ground station to everybody. It was one of the last things that we had to kind of make sure everyone got familiar with after we finished our soldering and stuff like that. So we split up into our different components, to kind of focus on different areas in SRAD. We started some of the basics with Teensy. Teensy is just a microcontroller that we'll be using for a lot of our SRAD work. So we kind of started getting familiar with this and getting like the framework set up, getting Teensy Duino set up, just so everyone kind of has like a baseline area to start with. Some of our goals for the upcoming week is we want to get kind of up and running with the flight computer sensors. So we have already those purchased as well as the Teensy. And last year we had them kind of up and running, and we didn't get a lot of tuned data. There was a lot of like noise that came through from there. So it's one of those, we want to get up and running like once again, just to kind of as a proof of concept to make sure that everyone's kind of familiar with what's going on with SRAD there. And we want to start tuning those sensors and kind of get those up and running. One of the other things that we want to do with our SRAD sensors subsystem on avionics. So one of the focus areas for SRAD for avionics is a sensor system, which will go throughout kind of the different parts of the rocket. And I want us to kind of split these guys up into different sub-teams so that they can kind of focus on one of the other sub-teams that go behind the rocket. So they kind of have an idea of, what might be potentially useful sensors that we can use, or potentially useful data that we can collect, as well as what sensors we would use to collect that data in order to produce better rockets moving forward. One of the things we want to add with our flight computer is the ability to do one-off flights by using GPIO pins with a multiplexer, which we'll get into what a lot of those are later in the presentation here. And we want to begin our bill of materials, mainly for the ground station, because I think that one is the one that's kind of behind the most at this moment as far as bill of materials goes. All of our other subsystems, we kind of have somewhat of an idea of what we want to do. So really want to get kind of an idea solidified for the ground station, as well as begin those bill of materials.
Thank you, V.
Structures with Taylor.
So last meeting, we mostly focused on reviewing our old MMM designs from, I guess, the old design, and then whenever we were considering external designs, and then we had presented Gustavo's design last week, and then a design that I had come up with this past week. Brandon went ahead and did an open rocket of Zenith for us. That's what you see at the bottom here. Just kind of like a rough guesstimate of where we think the components are going to be. With just some rough weights of some of the stuff. We do the Cicerone in there. We're trying to, right now the predicted apogee isn't quite where we want it to be, but that'll of course change once we are more firm on more of the components. Going forward, we're working on a nose cone trade study. We're working with that alongside analysis. So analysis is going to go ahead and look at, I guess, 7 different options for us. And then we'll go ahead and consider that feedback into our trade study. And hopefully have a design or a decision for that by the end of the month. We're presenting all the new MMM designs that the members have come up with this Friday, and then we'll have a final decision on which design we're going with forward the following Friday. And then we are still continuing with pricing for the upper and lower airframe and for the different nose cones, since we're broadening our scope for which ones we're considering. Okay.
Paula is in person this week, so this is the first time presenting.
All right, so for 30K propulsion, last week we
building off of the reshuffling of our sub-team goals. Since I briefly mentioned last week, we did have sort of a realignment after we did pick the motor for Zenith. We introduced the test stand, so we had a mini lesson over the current efforts, the past efforts of our test stand, because we will be making a new one, which would be the third one that's currently ever been to the lab. So yeah, we did go over past efforts. So there's the capstone test stand that I'm sure some of y'all have seen in the lab, as well as the mini test stand in preparation for the one that we will be building. So we looked at priorities, constraints, and limitations. We did have a lab tour last Thursday. So just for those members, just last couple of part of the onboarding efforts that haven't looked at the lab. So they got to look at it last Thursday, and we'll be meeting tomorrow to start brainstorming for our test stand, for our new one. Also, we will be starting bi-weekly Kahoots, and propulsion members did get this cheat sheet that you do see. Just summarizing everything we did go over to make it easier to keep track of everything ahead of our Kahoots. So that was it for 30K.
Thank you. Now the man himself, Ravi Desai.
All right.
Yeah, Ravi.
For analysis this week, in the lab last Friday, I did a quick run through of Oberon parts, mainly sparked by the curiosity of Christian and Nikolai. But our standardizing units project, there's an exciting update from Mike and Will on the next slide, so they'll be talking about that. Then with our design team, the main task we're working on right now is the MMM FEA. So some of the progress we've made is that almost all of the parts have been CAD'd in NX, which you can see on the picture up there. And then this week and next, I would like for us to start conducting simulations on that and hopefully have a final product by October 29th, a couple Fridays from now. And we also got some good advice from meeting with Randy, our EEE advisor. So I have some more thoughts on that as well. And then on the other side, with our validation team, they will be working on the nose cone analysis with structures, as Haley mentioned. And kind of as a consulting sub-team, we want to provide a recommendation of which nose cone profile will be the best for Zenith. The way we'll tackle this is through OpenRocket and RockSim designs, kind of comparing Apogee simulations and rocket performance with different nose cones, and then some mathematical models. I know there's some good resources online and some Goose put into our drive. So we'll be looking at those and taking those into consideration, and that will also be due on October 29th. But now handing it over to Mike and Will to talk about the units project.
So this is something we want to try to do occasionally, is to get members to present a milestone or something huge they're working on. So your turn.
So one of the first projects we were assigned was defining a standing set of units with the help of all y'all, possibly an alumni, and Gustavo as chief engineer. Yeah, so these are going to be based on standard conventions that you typically see in engineering, the aerospace industry, and maybe not a priority yet, but mathematical reasoning. And yeah, so we can convert and make sure everything is on the same page.
So the help we need from everybody else in the rocketry team is to take a few minutes at your weekly sub-team meetings to discuss data, dimensions, and anything else that your team uses dimensions for and what you're currently using as those dimensions. And then compile a list and send it to either your analysis point of contact or Ravi. And this will give us a good starting point so we can focus on what will be most useful. Thank you.
Good job. All right. Next up is recovery. Carlos.
So the past week for recovery, we had our second week of onboarding presentations where we went over black powder systems, CO2 systems, and mechanical separation systems. We also made a template, or I guess a document to have all of our research for the CO2 systems. And hopefully that will be done by next Monday. And then next week, we will actually start discussing how we're going to implement the.
Okay, can everyone make sure you're muted? We can hear you right now. Thank you. Parsa.
Cool. Yeah, so we're gonna we're going to finish our research, and then we're gonna look how we're going to implement the chosen CO2 system into the bulkhead. And then upcoming for this week, we have the third week of onboarding presentations. We had our first session today where we went over parachutes, connections, and tender descenders. And then, like I said, the CO2 system research. And then we're also going to be splitting the sub-team into the ejection and landing crew as well.
Finally, we have Ozzy.
All right, so we actually did have a great week. This last lab day, we got together with some of the team members on SRAD Propulsion, along with the capstone, and we decided to go ahead and just make some minor modifications to the test stand that is existing. We did go ahead and mark out a bunch of different bolt locations that we're gonna drill and tap and bolt together. So as you can see on the top left picture, is kind of like a mock-up of what we're looking for. That's just the bottom base, and it's gonna extend from there. So that's what we were able to get done that one day. So we do want to finish it as quickly as possible because the capstone is ready to start. The hybrid motor capstone team is ready to start mounting some of their hardware to it. We did have a capstone meeting where we purchased some of the materials to manufacture the gaskets, which you can see there for the injector plate and bell, as well as some of the piping hardware. And we also did make a model of a 3D printed mold so that we can create our own like super simple resin combustion chamber for the motor. This combustion chamber is only going to be used for like presentation and for like testing with water. So it's not going to actually see any nitrous oxide use or any like operating pressure. So it is just going to be a mock-up for the team, but then from there, from this model, we will design the CAD for the actual combustion chamber mounting mechanism. So we got some pretty good stuff worked out. This coming Thursday, we're going to try to finish up the existing test stand so that it's all bolted together and firm and can withstand. I mean, it's not going to withstand much force, but it'll be good. That's all I got.
So I guess before we move on to the avionics lesson with V, some things that we'll be going over next week is going to be a little more information about the PDR, what we're going to be doing, who's going to be coming to the PDR, and just pretty much what we need for that PDR report. It's going to be a lot of work from the sub-team leads, Gustavo and I, and hopefully some of the members too. It'll be fun, so watch out for that. Now it's B going over avionics. I guess we'll save the questions at the very end. So. Sorry. Yeah, so this week's avionics. Following week, we're gonna have structures. Haley, you're gonna be coming up here. And then after that is gonna be analysis with Ravi. And of course, after every week, we'll have the Kahoots and we'll talk more about the awards next time. So fundamentals of avionics by V.
All right. So one of the fundamentals of avionics is our flight computers. So on our rocket, we have two flight computers. We have the Telemetrum V3, which is by Altus. And then our secondary computer is the Stratologger CF, which is by Perfect Flight. our flight computers are kind of these little boards that we put on our rocket to be able to determine the state of the rocket, to collect useful information on the rocket. So the main states are kind of denoted below on the slide. So we have on the pad, so when it's upright inside of the rocket prepared for launch, ascent, which is when the rocket is actually still moving upwards and we have a positive velocity. We have apogee, which is the point of zero velocity, or the highest point that the rocket will reach. We also refer to it as drogue. The main, which is released somewhere around 700 meters above the ground, and landed, which is really important that we collect our GPS location from there. So those are kind of the major states. The release for apogee or drogue will happen 1 second afterwards. And then the main is about 700 meters above the ground. And otherwise, just kind of some important information on why we have these different states and what their relevance are. Okay. So then we have telemetry, which is an important part of avionics. So telemetry is kind of a fancy way of saying radio waves. In this example, we use the ham radio band, the 70 centimeter band to be specific, which does require a technician cert. We use the teledongle, which is an adapter for our flight computer. So that way, for the telemetry, to read our information from our flight computer on our ground station. So it will take encrypted information, which encrypted information is only allowed for devices like rockets or UAVs. You can't actually send encrypted data normally over ham radio bands. But this will allow us to unencrypt that information and be able to uncompress it and do it on the computer in a much more graphical and friendly way on our ground station. And we use a Yagi antenna for this. Which is a directional antenna, which is 70 centimeters and 2 meters. It's designed for both of them. It's two are pretty common bands to work on. Obviously, we use the 70 centimeter here. So then we have the ground station. You can see an image of Altus UI, our actual ground station on the right there. That is just a generic image I stole off the internet. That is not my call sign. I do have a call sign, and I just didn't want to set it up for this example. But ultimately, Altus UI, or our ground station here, allows us to do remote e-match firing, which is really important for testing on the ground to make sure that our rocket separates the proper amount. We have live data tracking. So in the off chance that our rocket ends up in somewhere that we cannot recover it, whether it falls into a big body of water or maybe some animal steps on it or something, and we don't get to recover it, we're able to look back at the data and see potentially if something went wrong, where it might have went wrong. If the example was, our rocket didn't fire and then it, blew up for whatever reason, we can determine like, hey, why didn't it fire? Where should it have fired? What was read on the data? What was, the error in our data? We have mapping and tracking information, so we can actually view the path that the rocket took from ascent to when it landed, as well as, to that in a map, as well as getting the GPS information to know the last known location of the rocket at any time. We have live replay functionality, and what this allows us to do is we can actually export the data that we've collected during flight, and we can play it back in a live replay, which will kind of allow us to see like what it was like during flight. You can actually see it'll take the real times, the real data, and fire off the charges in simulation, just to kind of show what it's like to actually use the ground station, so people can kind of get familiar with that without having to actually experience the flight. You can see one of the major features we have here is age, which is the last time that we've heard from the flight computer. So the flight computer works at about 1 hertz when it sends data over. So we should be having data about once every second, and that age will denote how many seconds it was since we last heard from the flight computer. We have the status, which you can see again on the image. And the status will denote the, sorry, I'm not even say status, I'm gonna say state. The state will denote kind of where the rocket is. And we talked about the states kind of on the first flight computer. So we have pad, we have ascent, we have drogue, descent, and then landed. And then we have flight storage. So obviously all this information is stored locally on the flight computer. So that's something that we can collect afterwards. And this will actually allow us to export the data from the flight computer and store it locally in CSV formats or other Excel accessible formats, just to kind of work with a lot easier. We have, that came out loud. We have our SRAD GPIO pin system, which is one of the things that we're starting this year. So with our SRAD flight computer that we'll be developing this year, if you guys kind of remember, a flight computer is a bunch of sensors that are used to denote the state of the rocket. We want to add general purpose input output or GPIO pins. And effectively what these are is they will allow us to attach sensors onto our flight computer to produce one-off flights. And the significance of this is we can kind of, we can say like, hey, you know, we saw that structures really wants to know about fin flutter. So we can put strain gauges on the fins and kind of determine, you know, how much force is being under them. But maybe, you know, we only want to launch with those once, because once we have that information, we don't need to recollect it. It allows us to take these off and put on potentially other sensors that might be useful somewhere else in the rocket. So as you can see, it allows for one-off flights, data collection, allows for multiple sensors on one port. So we want to use something called a multiplexer, which you can see a diagram off to the right. And it's kind of like how your TV works when you can have, you know, the cable, the Xbox, the PlayStation, Nintendo Switch, all of that hooked up, but you're only going to see one output at a time. Multiplexer allows you to do that just with electronics. It'll say, hey, I'm only using one port, but on this one port, I can send you the information from 5 different devices and just switch between them so many times a second. So that way it thinks there's 5 independent devices plugged in instead of one device. So hopefully we're hoping to use this to help develop our future rockets, as well as our advance our understanding of our rocket currently, as well as any future rockets that we might make. So any questions? End of my slide. There's questions at.
Okay, yeah, that brings us, I guess, to the very end of our meeting today. So as always, does anyone have any questions? Ravi, can you check for me on Zoom? Yes, Carlos?
Is the rocket sim file for the CNET simulation, is that available on the OneDrive?
On the Google Drive, the RockSim simulation, you said?
Yeah.
Open Rocket simulation.
Yeah, Open Rocket.
Open Rocket, yes. I will have to check for you. If it's not, we'll add it tonight.
Okay.
Any other questions? Anyone? Any questions? No? Yeah. Any questions on Zoom? No, no questions. Okay. Well, I want to thank everyone for coming in person or in Zoom again. It's a pleasure to host these meetings every single week. I will be going to the Nook right now to get some work done. If anyone wants to join me, Adrian, if you want your dessert and your coffee, you can come. But yeah, thank you everyone, and we'll see you again next week and throughout the week.